Hey guys, it's Miss Adams, and in our previous videos, we've looked at just basic linear function rules, and now we're going to get into arithmetic sequences. These sequences should align similarly with the characteristics from linear functions, except now we're not going to be connecting the dots. We have discrete sequences. We don't know what's happening in between the term numbers. So let's fill in this chart. It says we're given the sequence 17, 20, 23, 26, and 29. It's asking us to find the explicit formula, the recursive, the domain and range, and then write it as a function. So I'm going to actually start off with a domain and range because we're given terms A1, A2, A3, A4, and A5. So that means my domain is those counting numbers. 1, 2, 3, 4, 5 ellipses. And my range is simply the sequence. 17, 20, 23, 26, 29 ellipses. From there, I can identify my first term, my initial term a sub 1 as 17. We also need to identify our common difference here. Each time we're adding by 3, so our difference is equal to 3. So I know I'm going to have a sub n is equal to a sub n minus 1 plus 3 for my recursive formula. Now for the explicit formula, I do need that first term again, so that was 17. So if you don't remember what it looks like, we do give you the formula sheet, but that's going to be a sub n is equal to a sub 1 plus n minus 1 multiplied by d, and your recursive formula is a sub n is equal to a sub n minus 1 plus d. And I'll go ahead and color code that for us. All right, so let's look at this. I have 17 plus n minus 1 multiplied by 3. I'm going to distribute the 3 through. So this is going to give me a sub n is equal to 17 plus 3n minus 3. And then if I combine like terms, I'm going to get a sub n is equal to 3n plus 14 as my recursive rule. And if I write that recursive rule as a sequence, I can replace my n's with x's to get 3x plus 14. Now sequence 2 has already given us the explicit formula broken down. So it tells us that a sub 1 is equal to 3, and it tells us that our common difference is 5. I can go ahead and actually write this as this sequence as a function. So I have a sub n equals 5n minus 2 from the explicit formula. So all I have to put here is 5x minus 2 as the sequence. I know my initial term was 3, and my common difference is 5. So 3 plus 5 is going to give me 8. 8 plus 5 is 13. 13 plus 5 is 18. 18 plus 5 is 23. And the sequence could keep going. So again, that initial term here is 3. And if I write the recursive rule, I've got a sub n minus 1 plus 5. So my domain is 1, 2, 3, 4, 5. And my range is the sequence 3, 8, 13, 18, 23. For sequence 3, we're given the recursive formula. Again, we have a common difference of 5 here, but we have an initial value of 7. So I'm going to have 7. 7 plus 5 is going to give me 12. 17, 22, 27, and it could keep going on. So I know I'm going to start off with 7 plus n minus 1 times my common difference of 5. I'll distribute the 5 to get a sub n is equal to 7 plus 5n minus 5. And that'll simplify to a sub n equals 5n plus 2. I can write that as a function by writing 5x plus 2. My domain, again, is my counting numbers 1, 2, 3, 4, 5, because I listed 5 terms. And my range is the sequence itself, 7, 12, 17, 22, 27. Now, for number 15, it says write the recursive formula, explicit formula, and function of the given table. So this table is basically like giving you the sequence 23, 21, 19, 17. Each time, I'm subtracting 2. So my common difference is -2. My initial term is going to be 23. So I need to write that down, that a sub 1 is equal to 23. You always need to write your first term for the recursive rule. Then I can say a sub n is equal to a sub n minus 1 minus 2. My explicit formula is going to be a sub n is equal to 23 plus n minus 1 multiplied by -2. I'll distribute the -2 to get that a sub n is equal to 23 minus 2n plus 2. This is going to simplify to a sub n equals -2n plus 25, which would give us the function -2x plus 25. Because this is a sequence, it is discrete. We've only been given the values 1, 2, 3, and 4. For our x values are term numbers. And then the actual terms themselves are 23, 21, 19, and 17. We can do similarly what we have been doing for problem 16. It says evaluate f of 2. So when our n value is 2, our output is 10. N value is 4. Output is 18. If a sub n is 14, then n must equal 3. And if a sub n is 6, n must equal 1. So if the value of the term is 22, what is the term number? Well, we could keep going with the pattern, and it looks like we're adding 4 each time. So 18 plus 4 is 22. So therefore, the term number is going to be 5. On 17, we're given the recursive formula. We need to write out the first 4 terms. So for A, I know we have 7. If I add 3 to 7, I'm going to have 10. If I add 3 to 10, I'm going to have 13. And 3 to 13 is going to be 16. I can do the same thing for B. My first term is -2. If I subtract 8 from -2, I'm going to get -10 as my second term. -18 as my third term. And -26 as my fourth term. For C, I'm going to subtract 2. So 4 minus 2 is going to give me 2. 2 minus 2 is 0, and 0 minus 2 is -2. For 18, it says write an explicit rule or formula to find the indicated terms. So I want to find the 28th term of the given sequence. I know my initial value is 0, and I have a common difference here of -4. So I'm going to have a sub n is equal to 0 plus n minus 1 times -4. I'm going to distribute the -4. So this is going to give me that a sub n. The 0 is not going to add to anything, so I'll have -4 n plus 4. And then if I find the 28th term, anywhere I have an n, I'm going to replace it with 28. So I got -4 times 28 plus 4. So therefore, my 28th term is -108. Again, I can do the same thing with B. I have a sub 1 is equal to 8. And now instead of subtracting 4, I am adding 4. So my common difference is positive 4. So we have a sub n is equal to 8 plus n minus 1 multiplied by 4. Distribute the 4 to get that a sub n is equal to 8 plus 4n minus 4. And that'll simplify to 4n plus 4. I then can say that a sub 18 is equal to 4 times 18 plus 4. So 4 times 18 plus 4 will give me the term value of 76. For problem 19, we are doing a little bit of real life connections to this. So Mr. Carrozza was at basketball practice and practicing his free throws. In the first hour of practice, he made 3 free throws. So that is what we're initially starting off with. He's making 3 free throws on that first term. In the second hour, he made 5 free throws, and in the third hour, he made 7. So to go from 3 to 5 to 7, we have a common difference of 2. So if I want to write the explicit formula, I'm going to have a sub n is equal to 3 plus n minus 1 multiplied by 2. Distribute that 2 out to get a sub n is equal to 3 plus 2n minus 2, or that a sub n equals 2n plus 1. We want to know how many free throws he's going to make in 6 hours. So anywhere we have an n, I'm going to replace it with 6. 2 times 6 is 12. 12 plus 1 means he's going to make 13 free throws after 6 hours of training. All right, guys, good luck on this test.